Hey, welcome to Automat Live Coding. On this stream we write Automat. It's a game-playing utility. It can press the keys, like according to macros that we can record. It can capture contents of windows. Please ignore this error message. The Linux version of window capture is kind of heavy, so it tries to capture them in a loop, which causes some issues. Anyway, we can capture the windows, and we can do OCR on their contents. So if I put OCR here, I can run it. It can tell me what is written here. It's not too great. It doesn't do well with noisy backgrounds. This is something we should eventually fix, I think. Yeah, this blue text on top is not going to work great. Or maybe it will. Who knows? It's hit and miss. Anyway, it is good enough to recognize short text snippets, for instance, in games. If you have a health bar and below health bar you have the number of health points, we can recognize that. And then we can use our scripting environment to make decisions based on that and maybe drink a potion or perform some in-game action for you or use a healing skill, something like that. So the core of logic in Automat right now is being done with those cards, with those instructions on cards. And they are implemented in a rather interesting way. So when we have a bunch of instructions that we want to execute and they are connected in line, what we do is we start a new thread, and in this thread we take all of the instructions that are on screen and we put them in memory as machine instructions. So those hexadecimal numbers, this is machine code that we are executing to execute this script. Then this separate thread executes, it just jumps in and starts executing the machine code. It's very fast. If you want to script anything like that, you are going to have a very fast script, actually faster than Automat itself. The problem is that to execute it in an interactive fashion, we have to read values of registers from this separate thread. And to do this, we have to employ some debugger-like techniques where we ask the operating system to pause the thread, then we can look inside, inspect registers, and display them on screen. If I can set the value to 100, I can run this assembly, and you can see that in our assembler thread, this box represents an assembler thread. We have a register set to, it says 64, but in decimal this is 100. If I set it to, I don't know, 9, you will see that it's set to 9. Or I can flip the bits. Yeah, those instructions are fun, very fast. But interesting. I would have to debug this. So today we are going to attempt a different approach at executing assembly where we do not need a debugger. Hopefully this is going to work cross-platform. So this debugger approach, I said it's a problem. It works, but it's a problem because it only works on Linux. We could port this to Windows. It's definitely possible. We can port this to macOS. It is definitely possible. but it's going to be very different across operating systems. And it's just a lot of work maintaining a debugger, a cross-platform debugger. So I would like to try a different approach. In this approach, we will execute assembly without a separate thread. We are going to use a fiber. A fiber it's more like a different stack. You can just create a different stack in the operating system and, run on it. And actually, we don't even need a different stack. We can execute this assembly directly. But okay, let's say in a fiber. I'm saying in a fiber because this assembly, it can be slow and it can get stuck. And Automat has to keep running, even though the assembly can get stuck. So to support this, we need a mechanism to interrupt the blocked code which is stuck in a loop. And the thing that we are going to use to help with this are signals. With signals, we can actually completely cancel whatever was executing in assembly and go back to executing the parent function. And with signals, we can not only completely interrupt it, we can also interrupt it, read registers, and resume the execution. So we can have assembly code which executes at full native speed and from which we still can read register contents whenever we want. Yeah, so this is what we would like to do today. And I keep saying I have all those AI agent subscriptions. So I would like those AI agents to finally do more work. So I have Copilot, there is Cursor, there is Claude, and there is Gemini. Gemini has a free tier. It launched 2 days ago, so we can test how well it works with our code base. Yeah. So the current version of Automat if I run tests, you will see that they pass. But this is because I'm using my own code right now. Yesterday I asked Claude to try to implement those fibers. I mean, we used to have those fibers, they almost worked. I just switched to this debugger approach last moment. It was a bad call. But I tried to ask it to implement it. It was super reluctant to do any work. It tends to just implement a function. It says, oh, I will implement this eventually. And it puts like return true or just some fake return. And then when it implements tests, unit tests, it realizes that the implementation is missing and it just adjusts the fake implementation to pass the unit tests, which is terrible. It's like literally how you should not do test-driven development. But okay, maybe we can actually work with it together to make it work. And I want to try Gemini. Gemini, here. So let's ask it to git unstash first. So Gemini is immediately also unwilling to work. I said unstash, and Gemini doesn't know which command does it correspond to. Okay, Git commands are super sensitive, so I'm not going to let Gemini run wild with this. But it restored the code from Claude, and now we can see that the tests, they don't really pass all that well. And okay, this is my modification. And also there is this whole new implementation of machine code, of our machine code sandbox. It was so it was kind of written by Claude. However, Claude took the good parts from our documentation and added a lot of bugs around them. So we'll have to message it a little bit to make it work. Okay. This Gemini MD, that looks perfect. This LLVM async test, I am going to... I will have to think about how this test is actually executed. So the point of this test case is to run assembly so that it runs in a loop. We have two instructions that flip between two different values, and I am starting this machine code, then changing some of the connections, and then updating the code to re-execute it. But now the execute can be blocking, so we have to run it in a separate thread. Okay, this wait for execution checks whether we are still executing after 10 milliseconds. We should be executing after 10 milliseconds, absolutely. And then okay, we are just checking if the current value of the array-x is 42. We are removing the connection, just flipping the connection so that it actually, we are redirecting our original instruction to another one, and we are doing the code update. And now it should finish. And the final value should be 1337. Okay, so actually this test looks good. Okay, and now we are left with our broken file, which during hot reload seems to fail. I'm not sure if we really have to dive deep into this. I would like to see if the agents, if they can make it work. So I will restart this. Now it's using the Gemini file. Okay, is this prompt complete? I think so, yeah. So nice. Okay, it's running a LLVM test. How is it looking? Okay, now I can actually, in the meantime, start reading how the Claude's implementation, how it works. We have this generate machine code. It would be nice if this generate machine code actually I really dislike when it comes up with a function that's only used in one place. It's just obfuscating. It's not part of the interface, this function. Yeah. Okay, it wants to replace implementation of execute. No. Okay, this doesn't make sense. The stuff that's happening here. Generate machine code, status. You can just inline this. Okay, first of all, this update function, it can be called on a different thread. So it should first interrupt any machine code that could be running right now. Let's see. Should be a function. For creating fake user context. This is used for fibers, I think. I wonder if this is available on Windows. Okay, our controller definitely needs some kind of mutex. G, active signal controller, there should be no globals. Yeah, something like that. Executing thread ID. And even then, it should probably just protected by I'm not sure if this can be done with just atomic. It probably needs a mutex. Okay, let's let it work. And I wonder, the prompt that we gave it initially, I am going to copy this and we will see how Claude is going to be able to deal with it. Yeah, I am going to let it work. Maybe it has some... It actually looks like it has some idea of how it should work. The fact that it's using set jump is probably kind of obvious. I always tend to do those things manually by copying registers into some struct, but set jump makes more sense. It also saves stack, I think. Oh yeah. It should definitely be removed. So people often complain that those models, they are reading your data as you run them. This is a situation where I really wanted to read my data. I wanted to overfit to my data. I mean, it would be nice if I could edit this command. I don't want to specify that I'm allowing this each time. I actually wonder, I have these tests, right? There are some pragmas. Okay, how is it doing? I'm looking at this and I don't know where is the main function actually defined. Gtest Actually, wait. Yeah, it's here. Interesting. I could implement timeouts here in C++. Sorry, what? It removed infinite test? Why? I asked it not to remove stuff here. Yeah, this is the problem with agents. They tend to ignore what you tell them and just delete your code. Oh, we cannot pass this test, let's delete it. This is the agent-based test-driven development. Okay, what is it doing now? This doesn't make much sense. There was already thread in start execution. What was it? Here, and specify true and get a separate thread. You know what? The next time it asks me, I'm going to ask it to revert LLVM asm test and never touch this file, because it has been shown that it can work just like it is right now. So I can already see this is a waste of time. This is like this interview with a candidate who's just struggling. Like, it completely stopped changing the machine code. It's not touching this file. Now it's changing the test file to make sure it passes. Actually, this condition variable kind of makes sense. It's probably not a problem, but oh, it's going back to the actual file. This already could be just an atomic function, and then you don't need mutex and condition variable. You can wait on an atomic. So the model actually, there is some point to this. We should probably wait for the thread to properly start executing, but it's kind of the point of this function is that this function is going to block. So at this point we would have to unlock the variable. And while the model is working on that, maybe we can add this variable for it. This atomic. Yeah, so this is how you can do very simple locking. It guarantees that the thread has started when we exit this function. Actually, we only have to do this here. Is this another function which is only used in one place? Yes. Fantastic. So this function update code, it should check if there is any thread executing the machine code, if there is such a thread. Then it has to be interrupted so that we can load the values of registers. Okay, and we are sending QSR1. Perfect, this actually looks perfect. This while loop here, this one probably doesn't make sense. Because the thread which we are stopping, okay, it's switching to mutex, yeah. That's how it should be done. If it's switching to mutex, it can stop using the atomic. Anyway, I think even if with the signal, the thread which is executing this code should still be marked as executing, because we want it to pause it just for a brief moment to put an extra function on its stack, dump registers, and come back. It's actually great. The thing is, execute has a mutex? Execute should not have a mutex. Okay, I'm going to give it some more space. I will let it use all of its context, and if it cannot fix the test by then, I'm not sure, I may give Claude another go. I am a little bit afraid of allowing it to execute all timeout commands. Or all Python commands. I was thinking about doing a parameterized test for this extra class, but it's probably no need, so. Okay, we are just 15% through the context.
Martin Husky says,
"Hello, bro. How it's going mastering Streel?"
Hey.
Hi, bro. How it's going self-mastering?
Right now I'm kind of not really mastering myself. I'm trying to make the agent do some useful work finally. It has been promised for so long. So it's hard to make agents useful in the context of Automat. This is a visual tool, it's a graphical application. So this is the perfect use case, like writing small utilities, like a class that controls machine code. If agents cannot do this, then yeah, then they aren't very practical for writing new code. Debug code controller. Okay, it's set to true now, I see. Oh, I know, there is one more thing I wanted to do. I can use a different terminal for this. So, Tracy, right? I was playing during the last stream with this tool. I am going to clone its repository again. Yeah. Okay, this was not used by the project. Actually, yeah, there is this profiler.
Do you know to check well Win11 scripts to avoid ransomware or other VR? To be sure, system it's clean.
It's a miracle I understand what you're speaking about. Run this in a sandbox. Windows is the primary target for all sorts of malware. By the way, when I configure this, including X11 support. So I'm building this utility. It's amazing because I want to switch my debugging workflow entirely to Tracy. It's the view that it presents is it's actually much better than what I see in console when I just run Automat. So I'm thinking I will probably modify my logging macros to actually also output Tracy messages at the same time. I actually think it's getting somewhere, this model. I would have to read... Oh, it's so much code. Okay, this is our signal handler. It shouldn't be doing long jump. Absolutely not.
I mean about some tips how to clean well Y11.
If the malware is written well, then it's going to be very hard. Then the solution is to backup your data and reinstall the OS. Yeah, basically that. Everything else is just hoping that you will... that the malware author forgot something. What is this? So when this model, when it writes code, one thing I'm missing from here, it doesn't seem to think about preconditions and invariants that are going to be maintained through the code. It doesn't actually want to create some logical structure. It performs very surface level changes where it fixes issues. Those fixes locally, they may make sense, but I don't see any global structure in this implementation. For instance, it's using mutexes and atomics at the same time. It's using global here, another value with the same name here. This is just a recipe for disaster. Not. It's adding more of this. Code updated, store false. And this should not be necessary. Code updated, store true. There should not be code updated in here. It should be just updated in memory. Okay, I think Gemini entered a loop. Let's try switching to Claude. Okay, goodbye.
I think I have encrypted into lesson space in 970 OM2. I already written 100 TB. And you can imaging if you clean when scripts are still available.
Okay, I will copy this prompt again, because slowly improving the problem description. It's nice that it has this planning mode, but this planning mode, it doesn't have a step where it actually considers different design, like how this could be organized. Like, yeah. I could almost bet that it's going to try to fix tests by disabling them. So I don't like having a lot of state, because this state that is encoded here this is a copy of the state that is already in the machine. The processor stores this state. Like this executing thread ID. I mean, this one actually is kind of necessary. So bad. And how is the Tracy? Okay, that was Gemini. Look at that Tracy profiler. Let me grab the manual. Tracy has a fantastic manual. Can open it here. One day we should do all of the achievements from the Tracy profiler. Those tokens are going to run fairly shortly. We already crunched through 1,500 out of 7. I will see how far this agent can get us. Oh, it removed the repeated code. Probably shouldn't work. Shouldn't look at that because it's only going to be frustrating. Okay, naming threads. This is something I wanted to do. I have my own function called setThreadName. which does that. I think if I run Automat, I should be able to connect to it from Tracy. Okay, so this stuff that we have here, this is Automat's execution. This data loop, this thread is actually related to Pipewire, I think. But we have a couple of them like VK recorders. There are 4 identical threads. Some more unknown threads. I have no idea what is this one, this just Automat. Okay, so I would like to add this. It seems like we are setting the names of threads correctly. I would like to add another parameter to our setThreadName function, which is going to be the thread group. Let's see how this works. Tracy slash common Tracy system. And what do we have here? It gave up. It gave up. Okay, I think we can consider this a failure. It's just wasting time at this point. Okay, let's forget about the threads, although maybe I can implement the thread names using the Tracy's approach. Okay, I am passing a different group ID here. See if this will actually make those threads look similarly in Tracy. Okay, Automat is running. Wonderful. Let's connect. Okay, those threads are definitely next to one another now. At least we have that. Invisible threads. It doesn't seem like they are grouped actually. I'm not sure what's the point of grouping. I guess we can keep it. Here's what I will do. I will remove all of those platform-specific definitions and we will rely on the library. Okay, time to look at the machine code. Actually, we are going to work on it a little bit. So there is this context that is being passed to signal handler. I want to make this signal handler use the v context to find the signal controller object, if present, if there is any present right now. That would be perfect if we can make it work. That would avoid those global variables. Probably skip this execution and I had all of this implemented, so let me find this. Okay, so with this regs other. No threads, no atomics. We are going to have one mutex.
Spontaneity 8 says,
How is it going? I don't really have some special tasks for today, just chilling and learning Pi.
Nice. If you're learning Python, Python has a good tutorial, I think. The official one. Not this one, this one. It's written by the authors of Python, so it touches a lot of like interesting and unique features of this, which are often unused. Okay, I have to reduce the size of code because this is going to be, maybe switch to full screen, because this is going to be a rather involved operation. So I could use thread local variables to store this information.
I'm gonna take a look. I need Pi for the masters, if you remember. It currently uses C, and working as web dev, I hope C and Pi will be usefully in future.
So what should our signal handler do? If active signal controller is missing, I guess we should log something and just continue. This is going to handle just user signals. And I can probably move this signal handler below the controller so that we have access to the definition. Move all those pointless variables. There will be no long jumps, nothing like that. Okay, this trick allows me to move all of the signal handling logic into signal controller. Follows non-static declaration. Cancel requested. Wow. Actually, no, I'm going to just delete all of these private state is initialized. Come on. And I think this should be to context. None of those things. Don't need any atomics. So we will have a mutex because this machine code controller is going to be entered and used from multiple threads. The transition when the execution begins and finishes, it's rather sensitive because then we are like, it can be executed on one thread at one point and then from another thread at a different point. So this transition should be atomic. We will use mutex to do that. We can store executing thread TID, yes, perfect, in a variable here. And we should also probably have some space to put result. Execution. I mean current registers. But I wonder if those registers should be protected by mutex or not. Probably not. So let's say I have this struct called regs. I think it's the same struct which is used in get state. So the flow is, when we want to get the state of assembler object, we log the mutex, we are checking if any thread is executing currently this signal controller. And if there is no such thread, then current state represents the state of this object. But if there is an executing thread, then we will send a signal to this. The signal will come back here on the target thread, and here we will copy the state into the state variable. And potentially we will exit. Okay, so this way we can copy out the registers. Okay, so it's our signal handler. So when we start, yeah, we should probably do something similar that we are doing below. We should probably allocate some memory for the code. Actually, when I'm looking at this, I think we shouldn't store the whole state, because if there is no instruction being executed, this will be empty, and we already know this because this was 0. I think it will be better if we just store the regs. We'll have something very similar to this. I'm not going to have any extra stack for this thread because we don't have extra thread. So nice. 1 page. Let's allocate 1 page in the constructor. Okay, and setting the signal handler, yes. We will not do this in the constructor, though. We will set and disable the signal handler only when we start executing the code. Okay, what signals do we have available? SIG info is a signaling for SIG power. Power failure, okay. SIG alarm is a timer signal. So we can use two user-defined signals. Should totally use both of them. And I'm also thinking that maybe SIG int would be okay. So the current thread, the current assembly thread, when it receives SIG int, it will just interrupt the assembly execution. I think it shouldn't mess up with Control-C, because regular Control-C, I think it should be delivered to the main thread by default. Not super sure. Actually, no, the only thing we need is, we just need two signals. One to get state of the assembly, and one to cancel it. Or actually, we can also cancel it, but like pause it. It can be paused. You know what, let's just use two of them. I'm not going to complicate it unnecessarily. think when I call sig action, this tells me what was the old signal. It's so complex. I think this old signal should be saved. So while we are executing, okay, so this is apparently I don't know if I should call this or not. Maybe I should just return from signal handler, that should be fine. This is going to be called when we execute. So here, this is a perfect example. We want to update the code which is currently being executed. And we can do this by doing the lock. We can check if there is an executing thread ID. If there is an executing thread ID, then we should pause. send a signal to this thread, and then we have to, because this update code is synchronous, we have to wait for the signal to be delivered. So we should have some kind of waiting mechanism. Actually, maybe I could do this differently. I think we can actually mess with this uContext. I think
$240 Bacon says,
Best viewers on streambrew.com remove the space while they...
okay, there is an instruction pointer, so we could theoretically change the return address by messing with this RIP. So when a signal is delivered, our thread, which is executing assembly, it's not going to save those registers. It's going to put the context pointer in an atomic variable. This will be set to null almost all the time, except when we want to communicate with this assembly thread. So I am going to put this value in this variable, and then I am going to wait until it's cleared. And when it's cleared, the execution will resume. This very simplistic signal handler allows us to mess with this struct from another thread. Yeah, I'm going to use the hardest memory order here, because it's a very weird thing that we are doing. Okay, I think the rest of this update code will probably steal from this loop, or not, or this. Actually, I'm thinking of a better way to do it. Yeah, I don't want to mess with the stack of this other process, because possibly I could put a function pointer and the signal handler, which I don't see anywhere. It could just execute this callback. That would reduce the locking. I'll think about this. For now, I will do this synchronous blocking approach. I will plan this. Use the RIP to find the current instruction. So we should maintain some kind of a map. So this is going to resume the execution. I mean, not necessarily. This will either resume the execution or call another of those update functions. Okay, let's continue with execute. So we can log the mutex. If there is a thread which is already executing, then we cannot execute assembly on the current thread. I don't want to just return an error. I would like to... It's going to be blocking anyway, so we can do blocking here. So we could theoretically execute in parallel, which will so I'm not sure I want that. I think if we want to execute in parallel, we should have just two machine code controllers. I mean, we could cancel the other execute. And honestly, I think probably returning the error is the best approach. Because blocking the caller is very bad. There is no way for the caller to know if there is another thread executing. Yeah. Is this madness? Use the map. Inst address, and we will execute it by jumping there. After the execution is finished, the assembly is going to actually properly serialize all of the registers for us. Actually, signal handlers should be installed and uninstalled here.
Wantoninity 8 says,
Just a off-topic question. What do you think about Web3?
Web3 being this crypto-based web, the one based on blockchain. I'm not sure. There are many definitions. Like yesterday, I've seen a talk where somebody said that Web3 is the web of agents.
More for blockchain, smart contracts. Do you think there is a future there?
Yeah. The Bitcoin network itself is, like all of those networks, they are very limited in terms of their throughput, so they cannot really process too much data. But for some big institutions like banks doing international transfers, this could be very useful. And if this Ethereum works, I mean, it does work, but Ethereum still has very limited computational, capabilities. Whenever you want to make a smart contract that actually involves some bigger computation, you always have to delegate it outside of the Ethereum computer. I think there are use cases, and there will be more use cases in the future. NFTs are a silly idea, but even NFTs, for some things, for smart contracts, the NFTs make sense for smart contracts, mostly. In terms of cryptographic solutions to real-world problems, they typically seem like a great idea, but in practice there are often ways to abuse them, and cryptographic solutions have this problem that when it fails, you often don't know that it failed. The failure scenarios are not mathematical in nature, they are often social in nature. Somebody steals keys, or somebody abuses the network in some way, like takes it down with DDoS or something like that. So I actually think Bitcoin was DDoSed many times. I don't know how resilient it is right now, but there were those manipulations where people were DDoSing Bitcoin to sink its value, to buy it, then stopping DDoS, and then selling when the value bounced back. Pretty nasty stuff. I've seen some games based on blockchain. I don't see much value there.
But on the other hand, somebody needs to control cryptocurrencies, right? It's not just there, existing.
Yeah. So this is actually the argument for Ethereum. It's that once you set up the rules that govern a cryptocurrency and you set them in motion by running this on Ethereum, then there is no controller, literally. There is a code that you let go and other computers execute it, and you have no control over it anymore. The thing is, this code has to pay for itself, so once it runs out of money, it stops. But this is actually the elegance of those smart contracts, is that once they are signed, the network makes sure that they follow the rules.
I used crypto for transferring money because basically there is no tax on transactions. I used XRP for that.
There is still some kind of payment that you have to do, right? To the network. But the payment is proportional to the compute cost, not to the amount of money. cancel? How do we cancel a thread like that? I guess we should we'll do it differently, of course. Oh, this is a very concise implementation if we forget about code emission. How do we implement cancellation? Maybe it's a change state. Or we just clear the current instruction.
Zephyr says,
Hey, we actually have to be clever here. Because if the code is executing and we are being told that state current instruction is null, I think that should be we shouldn't do that because execute could block, so set state inner could block. Okay, the stuff that we are doing is going to be very, very lightweight compared to the old approach. Okay, it's not compiling, why? So Automat should run now, but we still may have some, I mean, assembly is not working right now. We'll have to implement all of those to-dos now. Okay. It's not working for unclear reasons. I know. I'll be right back. I don't know why it's crashing Automat now. Maybe Automat is calling some of those functions during startup. Or actually the initial state already is crashing. It's installing Google Test. Invalid permissions for mapped object. Oh yeah, it's not writable. Fair point, fair point. I think I will just delete this. It will be just filled with zeros by default. And the tests should just fail. Nice, all of the tests failed. One test passed. How is it possible? Initial state, oh yeah. It verifies that by default we have arrayx set to 0. Okay, actually this part is implemented, so that's nice. I am going to try to use agents again. Let's fix the errors. So here we will have to remap or we do memset. I was actually thinking about serializing this into a separate variable, but maybe we can just write it directly into that memory. This is our generate new code function. Okay, and what are the errors? Okay, so I am taking the address of this regs structure xaddr. Oh, there was a macro that went through each register. I don't have it anymore. I even had some stack pointer magic here. Okay, I just need to save this somewhere. Okay, so this prolog function is a function that, if I remember correctly, it should take a single argument and it should jump to this function. So, to define it, okay, I think we should skip this. Yeah, definitely. Okay, and we continue fixing the issues. Nice bytes. Very useful function. Okay, we have this. Program is a vector of instructions. Nice. Okay, we are going to set this to the default address of 0, so we don't need that. Thinking about taking the emit instruction from this code. We'll need this map. exit points are going to look very different now. Hey. Okay, I think we should take all of those very useful functions. I think those fix-ups we can skip. Exit point is potentially different here. Yeah, because this is call. And this is not sure. And it's probably a return or something like that. Check. This is interrupt. Okay, this size is going to be different. How does the epilogue work? Oh yeah, I just need to call the epilogue. Actually, this is the address of the epilogue. Yeah, exactly. Jump target, machine code size minus epilogue prolog size. Okay, that should be correct. New exit points are way larger than before. Instead of 1 byte, we have 5 or something like that. Okay, I haven't finished. I think now I have to do the memcopy of this new code over. Just this part. This version doesn't use prologues and epilogues. Okay, I should set map to new map. Cool. I think that should work. I mean, we can now update the code. We still cannot execute the code. But we have those helpful functions now. Okay, so here I am saving the current instruction, doing the... I should probably wrap it in blocks so it's easier to fold it. Okay, that to-do is done. We probably have a bunch more to-dos. Okay. Actually, can check this before installing handlers or changing this ID. Yeah, we can fairly early tell that we cannot execute. Okay, so execute is done, update code is done. Get state inner. Do we have any to-dos? Yeah. How do we assign it? Actually, I will just create a copy. I shouldn't move it, actually. Okay, so this should now work. Okay, set state inner. Okay, so those two to-dos are theoretically what separates us from the new assembler working. What should we do? Okay, this essentially means that we want to cancel. How is our epilogue looking? We are storing all of the general purpose registers. I would like to do all of this and all of this, but not this. I need like another epilogue which doesn't store the return address. I think since I have access to this state, this context, I could say array p0 I'm abusing this stack a little bit. Should work still. Actually describing signal stack. Okay, I'm not sure if I want signal stack. I want the actual stack. Like this RSP. Oh, I just realized there is a bug. So here I am kind of simulating the jump to the epilogue. I'm curious, does it pass any tests? It could pass more tests now. Single instruction fails. Okay, I'll be right back. Oh, we have a problem. Update code. Oh yeah, I kind of assumed that there is some context. TTX is null. Okay, we did execute some tests. They failed, obviously. See this single instruction. Okay, let's first decompile this code. Okay, so we are setting the value of array x to something and then calling, this is probably the epilogue. Honestly looks great. I wonder why it fails. Or maybe at the end of execute we need to copy the... Oh, at the end of execute registers should be fixed. I see, so maybe our function signature is wrong. Let's make it uint64. I'd like to see what is this exit point. Looks good, actually. I think we are trying to allocate the address for our machine code very low, as low as we can, actually. This will give us address within the code segment. $15. Okay, so it left the code right after this call here. Wait for execution. What's that? Exited. Oh, there is some exit callback. Yeah. What are we doing with this exit callback? Gosh. Error. Very interesting. Let me debug this. Okay, we are in the exit callback. Probably is optional actually. Boring stuff, and this is our code. Okay, there is a problem with exit points, because we clearly have finished with this only instruction that's in the program. The program is just single instruction, this one. And it should be reported as part of the exit point. It shouldn't be empty. So the problem with this call instruction is that the call instruction points right after code offset. So I think I should pass trap through. Apparently, here I need to pass through. Look at that, the tests are passing now. Infinite loop is now failing. think this execution should start in the background. This is what we should do. Because it's blocking the testing thread. Signal handler, no active signal controller. Fair point, we should set this when we start execution. Okay, infinite loop now crashes. I have no idea why it's so slow.
Low pass effect.
Okay, so we just got the signal. It would be nice if I could scroll this up, because just before this instruction there is another instruction. Anyway, we are getting a signal, and signal handler should intercept it. Did install signal handlers not work? Or maybe I just need to tell it to continue. Yeah, like that. Okay, something interesting is happening because we are in the next test and the previous test just failed. It failed with address not mapped to an object, so I guess signal controller, which was here, created for infinite loop, was destroyed and we started running the new test. Yeah, this is what must have happened. Because it says that infinite loop passed, but it took a long time. The solution is to clean up any threads that are executing when this is being destroyed. Before we unmap, we should first cancel. And infinite loop actually printed exit point 0, which is exactly what we wanted. This means that our stack hacking works. We can push from one thread onto stack of another thread. We can literally call functions on other threads. Okay, time to see how the hot reload is crashing. No idea why this is so slow. . . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay, there is this signal sig user, but it's fine. We are using signals to do our work. Sig user is not a problem. Now there is an actual failure. Where are we? An exit callback, okay. Okay, this is strange. We are within hot reload. We are on this line. We haven't started executing anything. So this thread must have been started here. Well, I think we should join with this thread if we can. Yeah, because it's calling a callback and it cannot be called. Okay. So this is a bug with testing infra here. I will actually make this a J thread. It was fine. Ooh. debugger again. I think it's actually going to work, this signal-based approach. Okay, right now we are in this teardown phase, the infinite loop test, and the background thread is it's trying to log the mutex. And apparently this is an invalid address. Okay, huh. This is weird. Teardown cannot read those variables. It doesn't make any sense.
CP Chica says,
I came here for bug report.
Okay, let's hear it. What's the bug report?
I see some parallelization code, so I'm going to assume some race conditions here and there.
Yep. Data races are not that bad, really. It's only when you care about precision, or when it leads to some kind of deadlocks. Otherwise, it's most of the time it's actually good to have data races because lack of synchronization means you can run faster. I can fix this easily. Yeah, like that. Still an error, okay. There's no right to be this slow. Okay, now we are on this line, so we are waiting for the assembly thread to finish. The assembly thread we're in the execute finished, we are running this exit callback. Oh, okay, I see. So because we used cancel, stop the execution. We should provide the address at which we interrupted the code.
I played a game of old chess and won, so for now I like it more since my win rate is 100.
And there are probably fewer bots that can play it. You could play it with Stockfish and maybe you could even win. Okay, instead of using 0 as exit address, I will use the old RIP.
So I asked AI to give me a list of things to do with my chess engine. And it said, beginner, 6 12 months intermediate, 3 6 months advanced, 1 3 months. Am I underestimating myself, or is A overestimating me?
Maybe AI is assuming that you're going to use AI to write it. This morning I gave more than an hour to Gemini to work on this machine code, and it produced such a massive amount of code that it did nothing.
AI assumed I use AI.
Only makes sense. Apparently this is a very tricky file to compile. Okay, infinite loop is still failing. Okay, user 1 is fine, user 1 is fine. This is the actual issue. This is a problem. I think this is the end of prologue at Q.
May I ask you for a brief overview of your custom build system for Automat?
Let's take a look. The starting point is the run.py file. This is just a tiny wrapper that runs the stuff in run_py directory. And the way it works is it works in a way very similar to make. It builds a graph of maybe I can start it here. Yeah. It builds a graph of steps that have to be performed. These steps are described in the make.py file. Make.py contains the main algorithm that does the dependency tracking and some helper utilities. Step is a very important class. This is what describes a single step. Each step can have a function that builds it, a list of files that come in, and a list of files that are generated by it. Some identifier and some extra functions that make it look nicer. And the graph itself, it is mostly automatically generated based on the contents of the src directory. If you look at the build file, build module, the build module is responsible for, actually there are two. There is first the src module. Src module scans the src directory. It creates a Python representation of all of these source files. And then based on those source files, the build module comes up with what object files have to be built and how they have to be linked together. Yeah, and each step in this graph, like linking, like compiling every file, it produces those steps that have to be executed. And once all of them are executed, linking can progress. And once linking finishes, sometimes you can execute just the final command to make it run. And the make module, when it decides which steps have to be executed, it looks at the modification times of files. So if some key file, which is a prerequisite to a rule, has changed, the rule will be re-triggered. And it also computes hashes, so it has some optimizations to make this fast and efficient. It's not really that fast and that efficient. I think there are probably something like Meson plus Ninja could be faster. but they are a little bit more involved. The whole point of this system is to make it run without any dependencies, so the initial build setup is easy. At least that's the aspiration.
And how do you handle Windows being Windows and it by default needing the key vars sourced in shell?
I do that, actually, yeah. I think there are some... libraries that actually needed this. What was that? Remember, I have so many libraries here. Honestly, don't remember where was I doing this. Oh yeah, probably somewhere here. Setup environment. Yeah, there is literally a function that does this.
I meant more in a way. Do you like wing it with creating base Windows shell session and just piping command into it? Or is there more magic to it?
Actually, no. If I remember correctly, what I've done is I've just executed this command to see what result it produces and hard-coded the results. And I think this is the result. So, for example, include path is to contain the MSVC tools dir, SDK dir. I just went through this, checked what include directories Windows uses and moved them over here. So it's not going to work with maybe some legacy versions of Windows Tools. And if Windows Tools releases a new version, it may also break the build. But I think I'm locked to some specific version of the build tools. Yeah, 2019. I don't think 2019 are going to be updated. So if I update them eventually, I will have to probably change those hard-coded include paths so that it works. Yeah, and this variable was necessary to tell Silang about this. I guess it's an understatement to say that this is actually faster and more reliable than starting external shells to call the Visual Studio config tool. They really overcomplicated the setup. Especially, this is everything you need. Like those variables, once you set them up, you don't need anything else.
We need synclude and clib. And cbindel.
I think it works. Oh yeah. Environment variables obtained from this. And running set. It should be easy to fix them if I ever update this. So I called cancel and now I'm waiting to join. This thread has only one stack frame. Oh, this is wrong. This is very, very wrong. Yeah. That explains it. Wow, all of the tests passed. That means we have an assembler that doesn't require a dedicated thread anymore. It executes all in a single thread. And it's much simpler. Okay, my signal handler shouldn't catch any more segmentation faults or illegal instructions or SIG bus. It only catches SIG user. That should be fine. Okay, apparently p-thread kill works using signals. Huh.
I think it'll use scans to keep my life simple and be like, hey, you just need Python to build this.
Scans is amazing. I think the best solution is to just make it part of your project so that it's not an extra dependency. Let's see if it works.
Yeah, those Python tricks with NVs.
Nope. And now we have a crash. Did I break the tests? No, the tests still pass. Oh, it's back. Or not. also have this get state. Maybe this get state is slow. One more check. Now I should be able to pause it. Okay, exit callback tries to relock a mutex, which I guess is already locked. Yes, it is. think we'll just remove this. Or there should be reentrant mutex. Cursive mutex. Unfortunately, we can easily lock up still Automat if we do it like that. We have to fix this, but it runs there in the background right now. I will have to look and think how those locks, how they are implemented in the assembler, because they are the problem. Yeah, we are creating permanent lock. I remove this lock. It should actually run fine, I think. But may have some data races now. So Automat right now is completely blocked, it cannot execute anything until we stop the execution. I think the current signal-based approach is probably faster also. Probably not by much. But still. Okay, so I guess on the next stream we'll try to somehow make this work on Windows, because that was the goal. We got rid of ptrace, so now it should be possible to have real-time assembly editing on other platforms as well. Yeah. We'll see if we can make it work. Okay then. See you on Monday. Bye bye.